Welcome to the OnRamps Discovery PreCalculus, a creative and connected approach course. The course curriculum is designed to deepen students' conceptual understanding of fundamental mathematical concepts such as functions, graphs, and equations to better prepare them for a rigorous university-level calculus course. The OnRamps Discovery PreCalculus course was designed using Wiggins and McTeague's backwards design approach. Backwards design is outcome-driven design instead of a traditional content-driven design approach. The design process begins with identifying the highest level learning outcomes, known as big ideas, that students should know and be able to do when they complete the course. OnRamps Discovery PreCalculus is organized around 7 big ideas, represented here as units, and the content is aligned with the Texas College and Career Readiness standards. This home screen provides access to each of the units. Unit 1, Functions, Rates, and Patterns. Unit 2, Algebra and Geometry. Unit 3, Exponential and Logarithmic Functions. Unit 4, Trigonometry. Unit 5, Limits and Rate of Change Functions. Unit 6, Exploring Other Coordinate Systems. Unit 7, Sequences and Series. This is the first screen that teachers and students see when they log into Canvas. The only difference between the teacher view and the student view will be that the grayed out left navigation tabs are only visible to teachers. Let's take a closer look at Unit 4, Trigonometry. Unit 4 contains links to background or prerequisite information needed for the unit, the lessons available for the unit, and the explorations included within each lesson. OnRamps Discovery PreCalculus is taught using an inquiry-based learning pedagogical approach. This course uses inquiry-based learning, a pedagogy designed to engage students in the educational process. IBL frames learning in the context of real-world exploration and allows students to struggle to solve problems with minimal guidance from the teacher. Therefore, the curriculum materials are organized into lessons that encompass specific explorations or inquiry-based activities. All of these explorations are meant to be completed in groups of 2 or 3 students with minimal guidance from the classroom teacher. Let's take a look at the background information. Note that the background is directed at students, reminding them of important trigonometry concepts that they will build on in the following unit. For instance, this background page shows the relationships between angles of a right triangle and side length ratios, also known as SOHCAHTOA, that the students should be familiar with. Here, students are shown that when a triangle is embedded in a circle in the rectangular coordinate system, how these vertical and horizontal components relate to the radius of the circle and sine and cosine. Lastly, the students are shown that if the radius of that circle is 1 unit, the unit circle, then they can deduce that x equals cosine theta and y equals sine theta, and even further, how substituting this information could be used with the Pythagorean theorem to derive the Pythagorean identity. Going back to the Unit 4 screen, we see that below the background link, there are 6 lessons. We also see that within these lessons, there are often online quizzes available that students will complete in Canvas. Let's go inside Lesson 18. Again, Lesson 18 provides students with additional background information, including a few definitions such as radian and degree, a reminder about how to convert between the two, and an explanation of special right triangle relationships that students should already be familiar with from their geometry class. Down at the bottom, we have the teacher support lesson, viewable only by the teacher. If the student were to click on this page, they would see an error message. The teacher support lesson helps the teacher prepare for Lesson 18. It includes the student goals and objectives for this lesson, instructor tips, a few possible student misconceptions, and a list of needed materials for conducting this lesson in the classroom. You can see here that Lesson 18 uses the unit circle tool. Therefore, the teacher would need computers available to students for this lesson. Now, if we go back to the student's view of the lesson, we can use this forward navigation button to go to the first exploration in the lesson, Exploration 18.1, Common Angles of the Unit Circle. First, students use the special right triangle relationships and their knowledge of converting between degrees and radians to fill in the degree measures, radian measures, and coordinate pairs for each of the angles shown in the picture. Next, students draw an angle that is not included in the picture and explain how to find an ordered pair of that angle. Last, students are asked a guiding question to help them see the similarities between certain angles on the unit circle and are prompted to generate additional angles that have this similar property. OnRamps developed a learning tool to provide students with practice and assess their understanding of components of the unit circle. In Student View, the students can choose between Freeform or Challenge. Freeform allows students to practice and get immediate feedback on their work. The students fill in each angle as degrees and then as radians, and then the x and y coordinate. If I were the student, I would fill in this angle measure 0 degrees, 0 radians, and you see the little green check marks show the student that they have answered them correctly. If, for example, I enter 0 for the x component or cos theta, and I get a little red x right here, I know that I am incorrect. The other really great part of this tool is the ability to type math equations. Here I know that the angle is 1/3 of 90 degrees, therefore it's 30 degrees, which will be pi over 6. So all I need to enter is pi/6, and it shows it as pi over 6. Teachers can also use the unit circle as an assessment tool. When the student chooses Challenge, the challenge version of the unit circle tool is exactly the same, except the teacher can add a timer. The score of this will be uploaded to the gradebook for easy assessment. The unit circle tool provides this assessment data in the teacher view that shows the student's name and their status meeting the assigned challenge assessment. For example, here test student failed with time 4:46. The teacher can change the challenge versus freeform option, as well as the time provided to the student. Maybe each week the challenge time gets shorter by a minute for a quick weekly quiz grade. These data are automatically added to the gradebook as well. Let's look at one more lesson, Lesson 22, the roller coaster. This lesson begins by explaining to the student that the activity brings together everything they've learned about trigonometric functions so far by building a roller coaster. In this task, students create a piecewise function comprised by a set of trigonometric functions in order to make a roller coaster. They are given a context from the Thrill Ride Roller Coaster Company to design the track and are given the following constraints. The entrance onto the track has to be at point 010. The exit is at 15:0. There are specific max and min values. The slope of the curve is 0 at the entrance and also at the exit. The curves must be smooth so there cannot be any disconnected parts or cusps. The track must be made out of numerous pieces, therefore a piecewise function. The Building a Roller Coaster quiz is actually just a place for students to easily upload their solution to this exploration. When the students enter this quiz, they again view all of the information regarding the problem. Then they are asked, what is the formula for your function? A text box allows for equation editing, so students can easily write out the exact functions for their roller coaster. Then, when students submit the quiz, the teacher will have their answers available through Canvas, which allows for quick and easy grading of the assignment. Thank you for taking time to look at the OnRamps Discovery Pre-Calculus curriculum. We look forward to future collaboration with you and your school. Please visit www.onramps.org for more information on OnRamps.